Exoplanets, which is the name of all the planets that are outside the solar system, is currently known to more than 4,000, and their number will only increase from year to year. However, what are the distant worlds? We still know very little. This is not surprising because the existence of exoplanets astronomers learn about the existence of exoplanets mainly by indirect signs. For example, fixing the change in the brightness of the star, when a tiny part of its light is blocked by such a planet. This method of detection is called transitive. But the very fact that many stars have their own planetary systems for about 20 years, no one is surprised. In addition to what we now know about the existence of other planets, we still have information about the size and orbital parameters of some of them. And it is quite logical to assume that if the size of an exoplanet is approximately the size of the Earth, and its orbit is not too close to the star where it is very hot and not too far away where it is very cold, there is a possibility that it may have conditions suitable for the development of some forms of life. Such a concept has been called the habitable zone. If an exoplanet is in it, it is a potential candidate for the search for extraterrestrial life. It is to such objects that astronomers, astrobiologists, and other explorers of distant worlds pay much attention. However, it is not easy to find out if there is anyone alive on an exoplanet. So far, the actual existing methods of detection of extraterrestrial life has not yet been created, but in the next decade, the situation may change. If to Mars or even a satellite of Saturn, we can send a research probe to study the atmosphere and surface and even get colorful photos. For exoplanets, such a luxury for obvious reasons is not available. But even on a tiny ray that has traveled a dozen light-years, you can learn a lot about the exoplanet. With the commissioning of the Extremely Large Telescope, ELT, which is scheduled for 2025, you can better study the surface of exoplanets. In the meantime, methods are being developed to learn more about exoplanets from the habitable zone. When light from the star around which an exoplanet orbits briefly shines through its atmosphere, some of that light is absorbed or scattered by the molecules that make up the exoplanet's atmosphere. By comparing the spectrum of radiation from the star and the spectrum of light that has passed through the exoplanet's atmosphere, we can learn its approximate chemical composition, because different substances have their own characteristic spectral fingerprints. So what molecules will tell us about life? First of all, of course, it's oxygen. On Earth, oxygen is the basis of life. Without constant biofeeding, oxygen from the atmosphere will disappear rather quickly, by geological standards, even if it appeared there for some reason at one of the stages of the planet's evolution. Therefore, if we find oxygen in the exoplanet atmosphere, it is very likely to indicate the existence on the exoplanet, at least something single-celled and photosynthesizing like our terrestrial cyanobacteria. But if there is no oxygen, does this mean that the habitability of the exoplanet can be given up? Indeed, if we take Earth, it took about 1 billion years from the origin of life to the appearance of appreciable amounts of oxygen in the atmosphere. And it would be a shame if we, having studied the atmosphere of some exoplanet, consider it lifeless only on the basis of the fact that there will be no oxygen there. As a team of researchers from the University of Washington and the University of California, Santa Cruz, writes in the Planetary Science Journal, even in the absence of oxygen, life can manifest itself with methane and carbon dioxide, provided there is no carbon monoxide in the atmosphere. Methane is another gas that organisms can also synthesize during their life processes. Learning to produce methane is somewhat easier for living organisms than oxygen. Therefore, early in the evolution of life on an exoplanet, there will be a certain amount of methane in its atmosphere. The problem is that methane in the air can appear not only due to life, but also due to completely non-living processes, such as volcanic eruptions. However, a new study suggests that it is possible to distinguish living methane from non-living methane. German astronomer Johannes Kepler is known as the discoverer of the law of planetary motion and the Kepler orbiting telescope as the most successful instrument to date for detecting exoplanets. At a recent NASA press conference, astronomers announced that they had confirmed the detection of 1,284 new exoplanets. This was accomplished through a new statistical method of analyzing data from observations of the changing luminosity of stars. To each potential exoplanet, the researchers matched the calculated probability that it was indeed a planet, rather than a random planet-like coincidence. In this video, I will show 10 unique exoplanets that have possible life and are almost nothing like our planet Earth. Scientists have several ways and methods of classifying the potential habitability of exoplanets. The key factor in this definition is the major semi-axis of the exoplanet, the average distance from the planet to its star, inside the habitable zone of the star. The habitable zone, in turn, is the space between the star and the planet, in which planets such as Earth can contain water in liquid form on their surface. Without this capability, the presence of the kind of life we at least know about on Earth is impossible. Of course, scientists test other characteristics of exoplanets before they are declared potentially habitable. For example, the composition of such exoplanets should be rocky rather than gaseous. In addition, the radius and mass of the planet should not exceed 0.5 or 1.5 and 0.1 to 5.0 are indicators of the Earth, respectively. Number 1. Planets made of water vapor. The exoplanets, Kepler-138c and Kepler-138d, orbit a tiny star 218 light-years away. Both are about 1.5 times the radius of Earth. In all likelihood, both have rock metallic interior. These are the first planets that can be confidently identified as water worlds. Thus, the average depth of the oceans on these planets may be as deep as 2,000 kilometers, 3.7 kilometers on Earth. Since the planets are very close to the star, their orbital period, 13 and 23 days, respectively, most likely there is very hot. They are enveloped in a thick and dense atmosphere of water vapor. And also because of the enormous pressure, water there can take the fourth state of matter to turn into a so-called supercritical fluid. Number 2. The Marshmallow Planet. TRAPPIST is a gas giant orbiting a red dwarf in the constellation of Ascendant, about 580 light-years away. Its density is comparable to that of a marshmallow, 0.27 grams per cubic centimeter. Jupiter has 1.33 grams per cubic centimeter. It is a very friable exoplanet, so much so that it is unclear how it could have formed so close to its star. It makes one revolution in 343 days. At the same time, it lives very close to a red dwarf star. Near this type of star is the easiest place to look for life, but there have been concerns. Red dwarfs are very active, often bombarding their planets with bright flares that can blow atmospheres off planets. TOI 3757b showed that light atmospheres can in principle persist under such conditions. Number 3. An ocean of molten magma. TOI 1075b is the largest super-Earth discovered to date. A newly discovered exoplanet just 200 light-years away may shed new light on one of the strangest mysteries of planetary science. The object is about 1.72 times the radius of Earth. The planet is among the largest super-Earths. Importantly, it falls into the so-called small planet radius gap, the existing deficit of exoplanets between 1.5 and 2 Earth radii in size. It is almost twice as dense as Earth, making TOI 1075b a contender for the title of densest super-Earth. Its orbital period around its star is only about 14.5 hours. It orbits very close to its star and it is very hot there. TOI 10175b has either no atmosphere at all or consists of metal vapor and silicates due to an evaporating ocean of magma on the surface. Number 4. Planets with barium clouds. Researchers were surprised to see barium at high altitudes in the atmospheres of the superhot gas giants, WASP-76b and WASP-121b. It is still completely unclear why such a heavy element, which is 2.5 times heavier than iron, is flying in the upper atmosphere of these planets. WASP-76b and WASP-121b are unusual exoplanets. Both are ultra-hot Jupiters. They are comparable in size to Jupiter, but have extremely high surface temperatures, above 1000 degrees C. Number 5. Waterworld. TOI 1452b is an exoplanet orbiting one of two small stars in a double system located in the constellation Dragon at a distance of about 100 light-years from Earth. Analysis of TOI 1452b shows that the planet is rocky, but water may make up to 30% of its mass. This is consistent with some natural satellites in our solar system, such as Titan and Enceladus. The exoplanet is located at a distance from its star where its temperature should be neither too high nor too low for liquid water to exist on its surface. Astronomers believe it could be an ocean planet, a planet completely covered by a thick layer of water. Number 6. The youngest. Astronomers studying the young star AS209 in the constellation of Serpentor were able to detect signs of an exoplanet with a near-planetary gas dust disk still around it. This indicates the ongoing process of formation of the celestial body. The Jupiter-weight infant is still orbiting in the amniotic waters of the young parent star, in the gas dust disk. The star AS209 is 395 light-years away from Earth. The AS209 star is only 1.6 million years old. This makes the planet discovered in its system the youngest exoplanet ever observed. Number 7. Planet Hell with lava rains. 55 Cancr E orbits so close to its sun-like star that conditions on the surface can literally resemble a biblical hell. It is less than 4 million kilometers from its star, with a day lasting only a few hours. Something mysterious is going on at 55 Cancr E because its hottest point is not facing the star. One explanatory theory is that the planet has a dynamic atmosphere that moves heat around. Another theory is that 55 Cancr E is still spinning, which is odd. It should have been kept from doing so by the proximity of the star. In this scenario, the surface would heat up, melt, and even vaporize during the day, forming a very thin atmosphere that James Webb could detect. In the evening, the vapor would cool and condense, forming lava droplets that would flow back to the surface and solidify again as night falls. Number 8. Giant with sapphires raining down. WASP-121b is a massive gas giant, almost twice the size of Jupiter. It was discovered in 2015 but studied in detail in 2022. The planet is very close to its star and only has one side turned toward it. It hosts the water cycle and more. The night side is cold enough to host exotic clouds of iron and corundum, the mineral that rubies and sapphires are made of. These clouds, like water vapor, can travel to the day side, where high temperatures turn the metals into a gaseous state. Exotic rain, such as liquid gemstones from corundum clouds, can form along the way. Number 9. TRAPPIST-1e. Orbiting the star. TRAPPIST-1 are the most Earth-sized planets ever discovered in the habitable zone of a single star. This planetary system is made up of 7 worlds. Water on most of these planets is likely to have evaporated early in the system's formation, Space.com previously reported. However, a 2018 study found that some of these planets could hold more water than Earth's oceans. One of the worlds, called TRAPPIST-1e, is thought to be the most likely to support life as we know it. Number 10. Sisters of the Earth. Planets GJ1002b and GJ1002c meet all the requirements for potential habitability and are only 16 light-years away. The 2 Earth-mass worlds are in the habitable zone around a red dwarf called GJ1002. Habitable zone is the distance of a planet from its parent star where liquid water, and therefore life, is theoretically possible. Not much is known about them yet. The next step will be to estimate their atmospheres based on the light they reflect or the heat they emit. That's all, my dear viewers. Thank you for watching. Like and subscribe to the channel. See you soon. Bye.